Welcome to True Projects. In this video, we are going to explain about a project titled Clustering Based on Supervised Learning of Exemplar Discriminative Information. The project focuses on utilization of clustering algorithm which aim to group objects based on their similarities. While humans excel at this task, machines often struggle to achieve the satisfactory result. The project delves into the advancement made in deep learning algorithm, particularly in the realm of supervised learning. These advancements have led to the notable improvements in the performance and efficiency, enhancing the capability of missions in tackling the clustering task. The objective of this project is to investigate the application of deep learning algorithm for clustering dataset without labeled information. More specifically, the project centers around the K-means KELMC and EPKELMC algorithm, which is the variant of the extreme learning mission algorithm. The project discussed the formulation of the objective function for these algorithms and how it can be used to improve the clustering performance. These are the basic requirements that are needed to build this project. Operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Wine Dataset. This module allows the user to upload the wine dataset to the application. This dataset contains the information about different types of wine such as the chemical composition and sensory attribute. And the second module is Pre-processed Dataset. In this, it includes the handling the missing values, normalization of feature values, and shuffling the dataset to ensure the randomness. The dataset may also undergo the label encoding or one-hot encoding to convert the categorical variables into the numerical form. And the third module is Run KELMC algorithm. This module applies the K-means based extreme learning mission clustering algorithm to the pre-processed wide dataset. This algorithm combines the principles of K-means clustering and extreme learning mission for clustering and classification purpose. The algorithm initializes the cluster center and calculates the exemplars, which are the data points closest to the cluster center. And the fourth module is Run K-means algorithm. In this module, the traditional K-means algorithm is applied to the pre-processed wine dataset. The K-means algorithm aims to partition the dataset into the predetermined number of clusters. It iteratively updates the cluster center by minimizing the within cluster sum of scores. And the fifth module is Run EPKELMC algorithm. This module utilizes the extreme learning mission clustering with ensemble pruning algorithm. It incorporates the concept of ensemble pruning and dimensionality reduction using the principal component analysis. PCA reduces the dimensionality of the dataset by transforming the original attributes into the new set of uncorrelated variables. And the final module is Accuracy Comparison Graph. This module generates a graph that compares the clustering accuracy of the different algorithms used. The accuracy is typically measured by evaluating the agreement between the clustering result and the ground truth or using the internal evaluation metrics of done index. Execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first folder is dataset folder consisting of wine quality dataset. And then the main and test is the main code files, and the run is a bad file. Instead of executing the program in command line interface, we created the Windows bad file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Wine Dataset button. Using this button, we are going to import the dataset from this folder of named dataset and then selecting the wine quality and named sheet and then click on Open button. Here, the dataset is loaded and we get a graph. Here, the x-axis represents the wine ID and the y-axis represents the number of records for that wine. And now close this graph. Here in this screen we can see the dataset is loaded, and the dataset there are numeric and non-numeric values, and the clustering algorithm will not take the non-numeric value. So we need to pre-process the dataset to convert the non-numeric data with the numeric value, and then click on pre-process dataset button. By this the dataset will be pre-processed and the non-numeric data is converted into the numeric data, and here the total records found in the dataset is of 6.97. The total attributes that are found in the dataset is of 12, and then click on run KELMC algorithm button. It is used to build the cluster with of KELMC technique. In this, we can see the 3 clusters are created, and each of different colored dot is in the different cluster as of 0 and 1. Now close this graph. Here it gives an accuracy of 94%, and then click on K-means algorithm button to generate the model width of K-means. Here in this graph we can see all the data is clustered into 2 forms such as of 0 and 1, and all the related data are at x-axis 0 and 1. And now close this graph, and K-means gives the accuracy of 0.23%, and then click on run EPKELMC algorithm button. Here in this we are building the cluster by applying the PCA and ELM technique. In this technique we can see that different color represents the one cluster, and the same data with same color are closer to each other, which indicates the proposed algorithm minimize the intra-cluster distance to keep the similar data in the same cluster. Now close this graph, and it gives an accuracy of 96%, and the total attributes after applying the data is of PCA is 12, and after applying the PCA is of 11, and it gives the accuracy of 96%. And click on accuracy comparison graph button. Here this bar graph represents the accuracy comparison. Here x-axis represents the algorithm range, and the y-axis represents the accuracy of those algorithms. And close this graph. Finally, I conclude that project proposed the KELMC algorithm and its expansions for clustering, which integrate the supervised ELM algorithm with K-means to build a partition learning algorithm from the distribution of exemplars. The objective function of the K-means is improved by adding the term that measured the classification error of exemplar, introducing the discriminative information based on exemplar into the clustering. The project shows that the proposed algorithm outperforms the other state-of-art clustering algorithm on several benchmark datasets.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.